Hi everybody. Okay, in this video we're going to talk about some more formulas, trigonometric formulas or identities. And these are called your double and half angle formulas. Now, we're essentially doing the same thing that we were doing with our addition and subtraction formulas. You're going to be trying to find angles on your unit circle. So for instance, these are your half angle formulas. So in this case, U would represent an angle on your unit circle. So one thing I do want to point out for sine and cosine, there are two possibilities because it's positive or negative square root of either 1 minus cosine of U divided by 2 or 1 plus cosine of U divided by 2. Okay, so the way that you determine whether it's the positive root or the negative root is based on the quadrant that the angle is in. Okay, so essentially you're finding sine of U divided by 2. So whatever U divided by 2 is equal to, which is going to be the original angle you're given, whatever quadrant that is in, that will help you determine whether sine or cosine is positive or negative in that quadrant. Okay. All right, so let's look at an example or a couple examples. So let's say you want to find sine at 15 degrees. Well, again, 15 degrees is not on your unit circle, but we could rewrite this as sine of 30 degrees divided by 2, because 30 divided by 2 is 15. So in this case, U is equal to 30, okay? So if you go back to your formula sheet, we're going to be using this formula where U is equal to 30. So essentially we'll end up just plugging in 30 here for U. Now, do we use the positive root or the negative root? Well, you go back to the original angle. 15 degrees would be in quadrant 1. And if you remember, all the trig functions are positive in quadrant 1. Okay? You can always use that little trick that goes, all students take calculus. Okay, so in quadrant 1, all the trig functions are positive. Okay, so this is going to equal the positive root of 1 minus cosine of 30 divided by 2. All right, and then you just think to your unit circle. Cosine of 30 degrees is pi over 6. So cosine of pi over 6 is 1 minus the square root of 3 over 2 divided by 2. Okay, now, in order to simplify that, we're going to start with our numerator. We're subtracting fractions, so we need a common denominator. So we'll convert the 1 to 2 over 2. And then we'll subtract our numerator. So we'll get 2 minus the square root of 3 over 2, all divided by 2. And then we will, because we're dividing fractions, we're going to multiply by the reciprocal. So under this radical, we're going to have 2 minus the square root of 3 over 2 times the reciprocal of 2, which is 1/2. Okay, multiply straight across, and we're going to get 2 minus the square root of 3 over 4. Okay, now, because 4 is a perfect square, we could find the square root of 4. So essentially, we're going to find the square root of the numerator over the square root of the denominator. Square root of 4 is 2. And so this is pretty much as far as we can take it in terms of simplifying. And I know it looks a little crazy because you have a radical within a radical, but that's okay. All right, that is allowed. So, okay, let's look at our second example. So here we want to find cosine of 22.5 degrees. Well, 22.5 is half of 45, or 45 divided by 2. Okay, so we're going to use this time our cosine formula, where u is going to be 45 degrees. And again, we're going to use the positive root because 22.5 degrees is in quadrant 1. Okay, so this will become the square root of 1 plus the cosine of 45 all over 2. And then we find cosine of 45 from our unit circle. 45 degrees is pi over 4. So cosine of pi over 4 is square root of 2 over 2 all over 2. All right, now we're essentially going to do the same thing that we did for number 1. We're going to find our common denominator. So make the 1 2 over 2. We're going to add our numerators. We're going to multiply by the reciprocal. So this will become the square root of 2 plus the square root of 2 over 4. And then we're going to find the square root of the numerator over the square root of the denominator. And again, that's pretty much as far as we can take it in terms of simplifying. Okay, now these are your double angle formulas. So double angle means we're finding sine, cosine, or tangent of 2 times u. And if you notice, for cosine, you actually have 3 different options. All of these are equal to cosine of 2 times u. So, you just have to pick one. Okay, so let's look at an example. Now, this time, we're actually going to revert back to our right triangle trigonometry for this problem. Okay, so this problem says we want to find the tangent of 2 times u if sine of u is equal to 4/5 and u is between pi over 2 and pi. Okay, so we're actually going to start by drawing a chorded plane. And again, if you think of your unit circle, okay, pi over 2 is here, pi is here. Let me make that circle. So this information here is just telling you which quadrant the angle is in, okay? And in this case, we're talking about the terminal side of the angle. So the terminal side of the angle is in quadrant 2, because that would be between pi over 2 and pi. Okay, so I'm going to draw, let's just say this is the terminal side of the angle. So we're really talking about this angle is in quadrant 2 and essentially intersects the circle at this point. Okay, now remember reference angles. A reference angle is the angle formed by the terminal side of the angle and the x-axis. So essentially this is our reference angle, but I'm going to call it u because remember that if you're given an angle and its reference angle, they both have all the same trig values, okay, or the trig values for those angles are the same. So what we're going to do is we're going to turn this into a right triangle. Okay. Now, we are given that sine of u equals 4 over 5. Well, remember, sine is opposite over hypotenuse. Okay, so in our right triangle, this would be the opposite side. This is your hypotenuse, okay? All right, so you have to find the third side of the triangle. So if it's not jumping out at you right away, you would use Pythagorean theorem, okay? It just so happens that this is a 3, 4, 5 special right triangle. Or 3, 4, 5 is a Pythagorean triple. It comes up a lot. So now, because the terminal side is in quadrant 2, to get to this point, you'd have to go left and then up. So you actually want to make that a -3, okay? In terms of plotting that point, you'd have to go left and then up. Left 3, up 4. Okay, now, we want to find tangent of 2 times u. So remember, the formula tells us that is equal to 2 times the tangent of u over 1 minus tangent squared of u. Okay, so the whole reason we had to draw this right triangle is so we could find the tangent of u. So the tangent of that angle, remember tangent is opposite over adjacent. So that's going to be 4 over -3, which is -4/3. That's what we're going to plug in for tangent of u into the formula. So this will become 2 times -4/3 over 1 minus -4/3 squared. Okay. The equal sign is kind of off there. All right, so now we're just going to work this out, okay? We're going to multiply 2 times -4/3. Now remember, that's like 2 over 1 as a fraction. So you're going to get -8 over 3. Okay, over. Now in the denominator, you want to evaluate your exponent first. So that'll become 1 minus 16 over 9. Because when you square a negative, it becomes a positive. And you just square your numerator and denominator. Okay, so in the denominator, we are subtracting fractions. So we're going to convert that 1 to 9 over 9, because we need a common denominator. And this will become -8/3 divided by 9 minus 16 is -7 over your common denominator. Okay, now we are dividing fractions, so we're just going to turn this into multiplying by the reciprocal. And then we could cross-reduce with the 3 and the 9, and then multiply straight across. We have a negative times a negative, which is a positive. 8 times 3 is 24, over 1 times 7 is 7. And we get our final answer. Okay, so again, you know, this problem kind of encompasses a lot of the different trigonometry we've talked about. So the right triangle trigonometry, you know, we talked about pi over 2 to pi is in quadrant 2. So, all right, we will definitely practice this some more in class tomorrow. Thank you for watching. Have a good night.